We begin by two-terminal element characteristics and define the linear resistor first. The symbol for the resistor is shown on screen. The value of the resistance is written right next to the resistor as R as shown on the screen. The resistor is connected between nodes A and B and has a voltage V of t and a current I of t associated with it. Notice that the voltage and current follow the passive sign convention. The behavior of the resistor is defined by Ohm's law, which gives us that V of t will be equal to R times I of t. If we were to draw this characteristics on a graph, where we have I of t on the x-axis and V of t on the y-axis, then the graph of the resistor will be a straight line through the origin as shown. The slope of this line, which will be equal to V of t divided by I of t, will be equal to the resistor value R. If we have another resistor, which we will also show on this graph as a straight line passing through the origin, and the slope of this line is also the resistance value called R dash. If we compare the value of the two resistors R and R dash, then the slope of the R dash characteristic is greater than R, and hence the value of the resistance R dash will be greater than the value of the resistor R. The units of resistance are ohms, which are written with a lowercase o if written as a word, or we sometimes use the Greek symbol capital Omega as shown on the screen. Ohms can also be written in terms of current and voltage. 1 ohm will be equal to 1 volt per ampere. There are two special resistance values that we will discuss next. The first special case is when the resistance value is 0. This characteristics can be shown on the graph as follows. Since the slope is 0, it will coincide with the x-axis, which we will just show as a dark line on the x-axis. This represents an element where the voltage is always 0 and the current through it can be any value. Another name for such a resistor is a short circuit or a wire, which represents a resistance of 0 ohms. We normally do not show the symbol of the resistor for a resistance of 0 ohms. We simply draw a wire between the two terminals A and B to show that it is a resistance of 0 value. The second special case is when the resistance is infinity. In this case, the characteristic looks like the follows. In this case, the I of t and V of t characteristics will show a line which is vertical and coincides with the y-axis. This represents a situation where the current is always 0 and the voltage can be arbitrary. We normally do not show this resistance by drawing the resistor symbol. We simply show that there is no connection between the nodes A and B and that we have an open circuit between the nodes A and B. We can also define another element called the conductance, which is the reciprocal of resistance, such that the conductance G is equal to 1 over R. The symbol is the same. We draw the same symbol as a resistance and write the conductance value next to the symbol. The units of conductance are the reciprocal of resistance, and they're called Siemens. When written in full, it is with a lowercase s, and when written as an abbreviation, it's an uppercase S. You have to be careful not to confuse the abbreviation for Siemens with seconds. In other books, it is common to write the units of conductance as mhos, which is essentially ohms written backwards, or occasionally to show the symbol, the Greek letter omega, inverted. In case of a conductance, the voltage and current are related as well, and the expression becomes I of t is equal to G times B of t. We note that a conductance of value 0, which is equal to 1 over R, implies that the resistor value is equal to infinity, which is the same as an open circuit. And a conductance value of infinity, which is the same as a resistor value of 0, is a short circuit.